Hello, everyone, and welcome to another Openshift Commons. We have a great show for you today. I'm really excited about, well, I'm excited about all of them, but today we have Christian Hernandez. He is GitOps rockstar, right? Openshift. If you haven't watched the GitOps Happy Hour, please check that out. That's on Thursdays, and he'll plug it later. We also have Andrew Block, distinguished architect and OpenShift guru, pretty much everything. And then Siamak is also joining us today, and he is an OpenShift product manager, and he covers all the stuff that you are interested in, right? GitOps, pipelines, a bunch of stuff. So again, it's an amazing group we have today. And we are going to kick it off with this GitOps in OpenShift with ArgoCD and Helm. And Christian, please take it away.
Yeah, so thank you very much. Again, my name is Christian Hernandez, technical marketing manager at Red Hat, and overall GitOps enthusiast, right? And so what I'm going to do is I'm just going to give a brief overview of GitOps and ArgoCD, leaving plenty of wiggle room for any questions or any comments that may come up. And then I'll hand it over to Andrew, who is like what was said, a general guru in terms of all things OpenShift, including Helm. So
polyglot. You're thinking of polyglot.
Polyglot, yeah, exactly. So it's one of the things that's I kind of just start with is what is GitOps, right? And it's really by definition, GitOps is when the entire infrastructure, your application, deployment, everything is fully saved and installed, represented in a Git repository, right? So generically, that's what GitOps is, right? So everything in your having to do with your environment is on Git. And so I usually just like to leave it at that, leave it kind of enough breathing room for there, because GitOps is it's an ever-changing, ever-evolving thing, and it really is a journey, right? So I I used to be in sales, right? And we always talk about like journeys, and that term kind of gets overused a lot, but this is literally I actually truly mean a GitOps journey, right? And it's really a evolution of what we brought with like the idea of DevOps and Agile, and actually Chris Short, as you may all know, the host of OpenShift.tv in 2018 literally said GitOps is the holy grail of DevOps, right? So it's really a really with the idea of DevOps practices, where we want to get to. GitOps is really that end goal, right? Where everything is described in a Git repository and everyone can get involved. So so really, like, why GitOps, right? So it's like, you hear this buzzword, it's like, well, why would I want GitOps, right? And so these are some of the challenges that GitOps addresses, right? I'll call out a few of these things. Like it takes weeks or even months to get me an environment. My application behaves differently in production than it did in test. These are some of the things that I in my life have heard personally. And things like production deployments have very low success rates. So when you take a look at some of these things that GitOps addresses, these are actually some of the things that DevOps addresses, right? So it's like, well, what's the difference, right, between like GitOps, DevOps? Like, how are they all tied together? A lot of the times people use these, it fits right in, right? They'll say DevOps and GitOps, especially us that are really into GitOps, talk about DevOps, because while DevOps is actually a culture, right? GitOps is actually that culture in practice, right? So it's really as Chris Short put it, I guess the best, which is why I always quote him anytime I present GitOps, is that GitOps is literally the holy grail, right? It's like I have a Git repo that everyone can contribute to, and it manages my infrastructure anytime via pull request, right? So so some of the benefits, right? You get it is that since it's all in Git, all changes are auditable, meaning like you have this convenient trail of all the changes that you've made in your environment, right? Anything as simple as someone scaled the cluster from 3 nodes to 4 nodes, that's in Git. Someone deployed a new version of application, that's in Git. So all the benefits you get from Git is by extension you get it in GitOps, right? So all changes are auditable. You get that standard roll forward, roll backwards in event of a failure. So you have the ability to, just like in Git, just like in your code repository, if you roll out a change and that change breaks something, you can always roll back to a previous Git commit, right, or a Git tag. Disaster recovery is I'll put it simply, reapply the current state of the manifest, meaning you just reapply, you lose a cluster, you just reapply what you have there in your the last known good state, and then you have the cluster up and running. There was a good article actually. I believe it was written actually by Weaveworks, who talked about a customer that essentially they restored their cluster in about 15 minutes, right? So they went from down to fully operational back in 15 minutes, and most of that time was getting storage backups up and running. So the experience is really pushes and pull requests, right? So you make a pull request anytime you want to make a change. That change can come from anywhere, right? There's obviously release gates in place, but the idea is if I as an administrator can make a pull request to the deployment code of the application because I want it to behave differently, and vice versa, right? So it's really, you have this whole convenient way of working together inside of Git, right? So Git already has that it has the practice of us working together built in, and we just take advantage. So and GitOps really is for everyone, right? So a lot of the times, people think that GitOps is really like a developer tool, and for a lot of time it is, right? You're literally deploying code using this practice, right? And I'll go over in a little bit about things like the sync tools, but in actuality, it's really for everyone, right? It's a DevOps tool, right? It's DevOps in practice. So you can't have DevOps without the ops either. So it's really for developers, for operations, for SRE teams, for it's really not geared specifically towards any core user group. So and so OpenShift and GitOps, right? So I always make the comparison, right? And I think it's going to become my tagline is like, it's like peanut butter and chocolate, right? So it's GitOps is a declarative method to declare what's in your cluster, and OpenShift is a declarative environment, right? It's built on Kubernetes, and so you have a declarative way of deploying your application in your infrastructure stack. And now you have a method platform that does that, right? So it kind of just like fits together, right? So all the declarations are in YAML files, right? So it's visually stored. You can have OpenShift suck that in and have it either modify operators or actually just do simple deployments. Like if you have just like a simple deployment service route sort of thing. It's all stored in Git, right? So it's a perfectly match. So some of the GitOps principles. So now this is the part where I always talk about how like this is a journey. This is where we are. This is where we are like now, right? This is kind of the idea that's where we are currently of like how to use a GitOps and OpenShift, right? So I always recommend separate application source code from your manifest YAML, right? So in the beginning, I always had the application source code and the YAML manifest deployment in the same repo. Actually, it's a lot better if you maintain those separately, right? So they have source code commits are independent from deployment commits. So all your deployment manifests are in standard Kubernetes manifests, right? Everyone says that there's a I'm a YAML engineer now. It doesn't have to be YAML, right? It could be JSON as well, but all those manifests are standard Kubernetes manifests stored in Git, right? So one of the big things is that what you want to do is you want to avoid duplication of YAML, right, across environments, and I'll go over that in a little bit, how that looks like, but and manifest should be applied with standard Openshift and K8s tooling, right? So there's really nothing new here that you haven't really been doing if you've been working with Kubernetes or OpenShift. There's not really any new tools, right, per se, right? There's a couple new tools, but it really is just kind of like a standard OpenShift and K8s tooling here. So really, like I said before, your day two looks really a lot like what you've been doing normally, right? For the developers out there, it's really just kind of like what you've always been doing, right? You've been doing a pull request, you merge the pull requests and then you run your pipeline, and it just automatically happens, right? So for the operations guys, I mean, for me, from an operations background, this is a little change. But it's really something that's been there for a long time, tired, tested, and true, right? So from an operations guy, when you hear that kind of just calms my nerves. Okay, it's tired, tested, true. People have been doing it for a long time, for years. Is this whole process of Git pull requests and merges, right, and automation. So all the changes are triggered from Git. I remember one day. This was a long time ago. I saw a talk by Kelsey Hightower, right? Some of you may know him. This is really early on in Kubernetes, right? This is like Kubernetes alpha, and he was talking about like Kubernetes is how you design a system when I take your SSH keys away, right? GitOps now, not only am I taking your SSH keys away, I'm taking away your kubectl away, right? So it's everything is driven from Git, right? And that's the whole idea. So there's one of the things that GitOps uses, right? And I think one of the things that's become very popular is a syncing tool, right? So a sync tool is really just it's built on native Kubernetes primitives, right? It's the whole CRD and custom resource definition that's built in Kubernetes, right? The way to extend the Kubernetes API is how these sync tools are built upon, right? So some of the things that a sync tool would do, right? The example on the right here, as you see, is ArgoCD, but you automatically detect drift and you correct it, right? So it's built on that control loop that's just built natively in Kubernetes, right? It'll see desired state and it'll see current state and it'll try to reconcile that, right? And so some of the popular GitOps tools for syncing is like things like ArgoCD, ACM, Ansible, FluxCD. Those are kind of just some of the big ones that bubble up when you're looking for tools that do the syncing, right? So it's really nothing new in the Kubernetes. And new, I mean that relative to Kubernetes, right? Is basically you're taking the concept of CRDs and CRs, and we built a tool around that to make sure their clusters completely in sync, right? So once you get like the CRD in place, right? Once you get your sync tool, there's a way to represent your entire stack in a manifest, right? So for example, the example on the right here shows an ArgoCD application, is what they call an application. And you basically tell it things like what server I want to deploy it on, what project I want to deploy it to, what the repo URL, what the path is, what the branch or tag name is. If I want it automated, right? Do I want to prune anything that's not in that namespace? So right, so you can kind of just declaratively say, I have an application. I want this to be deployed in this cluster, and I want you to watch this repo, right? And the entire stack, right, is in Git, right? All namespaces, deployments, ingress definitions, secrets, right? Operator manifest. And so usually the sync tool has a way of defining that, right? And this is kind of right here. Again, the example here is with ArgoCD. So the synchronization, this is a basic workflow, right? This is not like the end result workflow, but this is kind of just conceptually so you get an idea. The real workflow is a little bit more complex than this, but the idea is from a 10 million foot view is you make a change in Git, right? Either someone merges a pull request or you have some sort of automation that automatically approves certain pull requests and merges it. The sync tool will either via polling or push events or whatever, or in case like if you're using a sync tool like ArgoCD that happens in the control loop automatically, we'll then check the status, right? It'll check to see, okay, hey, the declared state says one thing and the current state says something else. So I'm going to go ahead and synchronize, right? I'm going to reconcile those two. So it'll change anything it needs to change, and then it will then do that in cluster. So one of the things, one of the issues, right? So there's certain challenges that come with GitOps, right? And there's like again, I could do a whole couple hours about this, but really is to avoid YAML duplication, right? So that's like one of the big things, right? So I can deploy these across multiple environments, but how do I manage this, right? Without, I have like 10 environments. How do I manage this without having 10 versions of the same YAML, right? So, that's one of the things that you have to look out for. And one of the things is to use templating tools, right? So there's all kinds of templating tools where you take a core YAML file and then you templatize that, right? So you have one core and then you may be changing a few things in that YAML file, right? So some of the popular templating tools are really customized, and Helm. So now that we have gotten to this part, right, is to templating tools with Helm. I'm going to go ahead and pass it over to Andrew to talk about a little bit about Helm.
Awesome. Thanks a lot, Christian. Let me go ahead and share my screen. We can go from there. Hopefully everyone can see the screen. So for those of you who don't know, Helm is a package manager for Kubernetes applications. So those of you who are familiar with typical package managers on your operating system, DNF, Yum, apt-get, Brew, which is kind of the unofficial for Mac OS, Helm has become the de facto packaging mechanism for packaging different components in a Kubernetes application into getting it deployed to a Kubernetes environment. Helm really consists of three primary pieces. First one is a chart. A chart really is just a set of related Kubernetes manifests. A typical application can consist of one or more different types of Kubernetes manifests, everything from a deployment, a service, maybe a config map, anything that can be deployed to Kubernetes environment and encapsulated into a single atomic unit goes into a chart. Now, once you create these charts, where do you want to store them? Make them more distributable. Those go into a chart repository, very much like an image repository like Quay, for example. And finally, a release. A release is when you want to install a chart from a repository, potentially. Its instantiation, its specific instance that's deployed to a Kubernetes environment is called a release. So how does Helm work? Really, it's just a combination of multiple components, all being orchestrated through a command line tool. So you have your chart and associated templates, values, which are the configuration inputs. So think of it as templates are their dynamic abilities to customize what your Kubernetes manifest may look like. So in certain cases, you may want to customize the image location, the types of resources that you want to apply to your application, maybe a liveness or readiness probe, along with other components. Those get combined with values. Those are the injected inputs for customizing those specific templates. So in certain cases, I want to use my dev image or my prod image, depending on what environment I have. Using the Helm command line tool, we'll go ahead and instantiate the two of those together and put them into a release that then gets installed to a Kubernetes environment. So here's an example of what a Helm template does look like. As you can see, a lot of the bracketed fields, those are the components that will be dynamically templatized and replaced by the values or other types of instantiated injection at runtime. So for those of you who are familiar with the Helm context, values.build.url. So when you go in and specify you want to build from a certain URI, you either provide that as a default value that's provided potentially within your Helm chart, or you can override that value at runtime. And for an example, a value file looks very similar to what it is here on the left. So basically, build.uri is this GitHub URL for some quick starts. That then gets combined at runtime using the Helm install command, and then you can specify a specific file. So you do Helm install, you give it the name of the release you want to create, you give it the location of the chart, whether it be from a repository or a local directory on your physical machine, and you specify optionally a set of values files or value inputs. And those go ahead and create the different type of resources that will be installed to your Openshift and Kubernetes environment. Now, this is where, very much like Christian said, the peanut butter and the chocolate start coming together, because we can go ahead and extend the capabilities that Christian mentioned earlier regarding using GitOps, ArgoCD, and this reconciler loop and integrate it with Helm. You can add charts that are stored in Git repositories or Helm repositories. So you can use many of the same principles that you've already leveraged, as well as including overrides for different chart values, whether they be complete files themselves or individual parameters. And we'll walk through that as part of the demonstration today. And all of this can be managed via the ArgoCD user interface, as well as the CLI. Okay, demo time, my favorite time of the day. What we're going to show today is a GitOps approach for managing applications as Helm charts. We're going to leverage the Quarkus Red Hat Helm chart, which is in Alpha. We're still curating it, to be able to deploy a Quarkus-based application to an OpenShift environment. And we're going to explicitly demonstrate how to integrate ArgoCD to really show you how GitOps can be used to manage not only your OpenShift cluster, but also using Helm. Sound good? Awesome.
I know I'm excited, yeah.
All right, give me 1 second. I need to unshare my screen for 1 second while I go find the super secret password, the cluster.
This is what I've been waiting for.
So we'll come back on the screen.
Sorry, what was the password?
1, 2, 3, 4, the same as my luggage.
There you go.
So in the background, I've actually deployed an ArgoCD environment. Oh, maybe I waited too long. Go back here, go ahead to ArgoCD, and we'll go ahead and log back in with the Openshift integration. And now we have our ArgoCD environment. So those of you in the chat, who here has never used ArgoCD? We're going to kind of walk through how to use ArgoCD together and how to add a Helm chart to it and then have it managed by GitOps. So just to browse around, for those of you who are unfamiliar with it, this is the home screen for ArgoCD, where you can define a set of different applications. And Christian, please feel free to interrupt me at being the all master of GitOps, in case you have any areas that you want to inject yourself into, for sure.
All right, yeah.
All right, so inside the configuration page, we have a set of repositories that we can set up. Certificates are important, especially when working in large, typical organizations that might have self-signed or industry provided certificates. You can add those so that your GitOps server, ArgoCD, can trust those destinations. Projects allow you to go ahead and configure different types of permissioning. So let's say you want to have certain teams get access to perform certain actions in certain OpenShift projects and namespaces, you can configure it there, as well as customizing the type of resources that you want to have be deployed. So let's say you don't want to give them access to create custom resource definitions or other specific type of resources. You can create whitelist and blacklist items as well. But in particular, I actually cheated here because I actually went ahead and added the GitOps Helm Quarkus application repository, which will allow us to basically kind of get really fast into this demo because we have a short amount of time. So this is our sample application, which is basically a hello world for Quarkus. Quarkus is a lightweight Java framework, supersonic subatomic Java for spinning up a Java application very quickly, very little runtime, very similar if you're familiar with Spring Boot, even faster, but using that microservices architecture for developing Java applications in the cloud. Actually, this would be the application. And it is basically a hello world. So we're gonna kind of demonstrate that in ArgoCD. So to add a Helm chart to ArgoCD, very much like you would any other GitOps-based application, we'll go ahead and click on Create. We'll give it a name, and we'll give it the name of the repository, which is basically GitOps Helm Quarkus. And of course, it took that. Go ahead and there we go. Let's go ahead and put the project, which is default. The default project comes by default, no pun intended, with your Kubernetes, with your ArgoCD based application. Now, Christian, do you want to talk about sync policy?
Yeah, so there is a the sync policy does you can choose one or two things, right? There's a manual sync policy, meaning that it'll just create the definition, right? It'll just basically create the instance in Argo, but not do anything, right? It'll wait for you to manually do the syncing each time it happens, either via an API call or whether you actually click the button that says sync, or automatic, right? So you can do an automatic sync policy, meaning it'll continuously monitor that repository and it'll automatically apply changes as they happen.
So I'm gonna go ahead and try to perform the automatic sync policy.
Yeah. So you have here also the idea here is I like to call out real quick is the prune resources, right? So the prune resources meaning that if it finds something in the namespace you're deploying to that's not in the repo, it'll delete it, right? So it'll you have the choice of either keeping things it doesn't know about or deleting things it doesn't know about. So that's a very important thing to call out.
I also told it to go ahead and auto create a namespace. So if I want to go ahead and deploy to a specific namespace that doesn't exist on the cluster, go ahead and create that as well. So I get a chance to pick from my configured repositories. I said I want to use the GitOps Helm Quarkus application repository. And that's not the one I actually wanted to deploy, which is kind of strange. Let's double check that really fast. This is basically my source control. Okay, cool. What we're going to do here is we're going to specify where is my Helm chart. And my Helm chart should be located at, let's go ahead and double check that, here, which is, don't you love live demos when things not necessarily go wrong?
Exactly. Yeah, it'll always.
Yeah. So we want to specify where.
Earlier.
Yeah, we want to specify where the Helm chart happens to be located. So the Helm chart is located here in the Red Hat Developer Organization. So we'll go here and demonstrate that. And we specify we want the Quarkus chart. We want to send it to the local cluster, which is basically, if you're familiar with Kubernetes, it's kubernetes.default.svc, which is the connection to the Kubernetes API in the local environment. And we want to send it to basically the same name of the application, which is GitOps Helm Quarkus. And we get a chance to override these value files. Now, if you're familiar with Helm, you'll notice that there are a number of values, everything from, at least from this chart, everything from where your image is located, where if you're performing a build, you can go ahead and build your application. You can, then on the deployment side, you can specify all the different parameters that you want to have for your application. So what we can do is we can either provide a file itself, or we can override certain values. And I'm going to go ahead and actually override a few values. Number one, we already have an image deployed. It's already out there in Quay.io. We're just going to go ahead and leverage it. So I'm going to turn builds to false. I'm going to scroll down and skip all the build stuff. Don't worry about that. We're going to go down all the way to the bottom, and we're going to specify the image name and the image tag. And once again, going to cheat here just because, like a good cooking show, just going to go ahead and go down and find the values that I want to leverage. And if you're familiar with customize, I am using customize here, which we'll show a little bit later on how to automate this entire process. So Christian, do you want to kind of talk about customize for a second while I go ahead and finish this up?
Yeah, so customize is another a way to template Kubernetes resources, right? So like the idea is that you have a single deployment manifest. Let's just take a simple example of a deployment manifest. And you know, you want to change certain things depending on which and on, right? So for example, the most common use case is the image, right? So the image that you deploy in development is different than deploying in production. The only difference is the image, but the manifest is the exact same. So what you can do with customize is you say, hey, when you deploy to this cluster, use this image. When you deploy to the other cluster, deploy the other image, right? And it's done using JSON patching or, you know, any other. There's a lot of ways to patch a customize, and you can do, again, another hour on just customize. But that's the idea of customize.
So all we had to do here was we modified two override values. We modified the image name, basically just pointing to an image out there in Quay.io, and we modified the build.enabled to false. And we're going to go ahead and click on create. And ArgoCD is going to create this application. And if you notice, it is deploying a set of resources. It's going to set up a service, a deployment, as well as a replica set and a pod. This is just an instantiation of our chart. Now, one of the benefits is you can play with this chart right now. I'm using the default chart, and if you go over to the developer perspective in OpenShift, you'll find this chart. And I don't need to see that. So if you go to add, there's this brand new, just go ahead and just pick on this just to have it. There's an entire Helm chart section of the OpenShift developer perspective to add. You can scroll down all the way to the bottom, and you'll see there's a brand new Helm chart. This is the same one that I'm using in this demo right now, so you can go ahead and give it a try in your environment. Obviously, still alpha, so it's still in a work in progress. As you see, Helm or ArgoCD was able to synchronize this application, and we have a route that was created, so we can access it externally. ArgoCD makes it really easy for you to query different resources on the cluster itself, all from a single interface, very much like the OpenShift web console. If we scroll all the way to the bottom, we can then see the URL of the application. Go ahead, copy it, open up a brand new tab, and you'll see we have, oh, GitOps loves Helm, just like that. It's great. But this doesn't really, it gets us there. We got deployed. We showcase how a Helm chart can go ahead and be used with ArgoCD, but we really didn't really emphasize the GitOps-based approach. I know Christian's like, this is nice, but we can do better, right?
That's right. That's right. We have the technology. We can do it.
We have the technology. So inside this example application, on the main branch is the application itself, which is basically, hello world, Quarkus basics. If you want to go ahead and deploy the application and build it yourself on your local machine, you can do that. But there's a GitOps branch that contains all the different manifests that you can use to not only demonstrate or spin up this demo in your environment, but we're going to leverage it to be able to manage our ArgoCD manifests right now. So let's go ahead and basically go back to our applications page. We have one application. We'll just switch over to the linear view. And we're going to use customize to basically stand up state environment. Sound good?
Let's do it.
All right. So on here, I'm going to go ahead and basically I have a set of manifests. And I have this Bootstrap application. A Bootstrap application is basically what they call in the ArgoCD world as an app of apps. Basically, it's an app that can deploy other apps. So I'm going to basically use customize locally to create an app of apps that will deploy and basically manage the application, basically the one that we created previously, but it's also going to create another application that will deploy the same application, but slightly different with different values for the production environment. That will allow us to, because with Helm, it makes it very easy to change some of the small parameters that really drive the configuration of your application. Let's go ahead and let's spin that up. So I'm going to do apply -k. That will basically allow us to use customized instantiation, ArgoCD face. And it's going to go ahead and templatize all of those customization resources. And as you see here, we have two new applications that were created. One is this Bootstrap application that basically includes two app of apps. One would be the application that we created previously, the GitOps Helm Quarkus app, but we have this brand new one, GitOps Helm Quarkus Prod, that represents our production application. We're using the same charts, we're just providing different values. And we'll walk through that right now. So if we click on that, click on that, you'll see this is basically very similar. Everything's been synced, everything's all green, everything's working great. We go look at the application details and we scroll over to parameters. You'll see we actually have a different parameter here. Under environment name, under deploy.env.name, we have a new environment variable called environment and a value called prod. Our application will go ahead and look for that environment variable and change how the application reacts. So if you recall, in our development environment or our non-production environment, we have a little blue background. Let's go ahead and look at the route that's exposed via this production application. We go here to the route, wait for the manifest to load, go all the way to the bottom. We have a different URL representing our production environment. We'll go ahead and open a new tab. You'll see we have our same application, but we have a different background that represents our production application. So as you saw, really easy for us to manage our our Helm-based installation and configuration all through ArgoCD, have it roll out, and have it all be managed in a GitOps-based approach. Christian, anything that you want to add?
I just want to add one little quick thing you mentioned, and I think it's worth calling out. Is you mentioned you have an application called an app of apps, right? So this is something that a lot of us do, right? In the GitOps world is we do an app of apps, meaning it's we try to solve the chicken egg problem, right? It's like, how do I deploy my application automatically without manually deploying it, right? So there's this concept of an application that does nothing but deploy your application, right? So it's kind of we try to solve that chicken egg problem there with the app of apps. And like to call that, which is something I do a lot, right? Is the app of apps as well.
Yep. So this really is the end of the demo. I know I'm interested in your feedback and especially the feedback of others here on the call, Karena, Siamak. You know, I'm going to probably turn it over to not Serena, Karena, pardon me. Karena, do you have any areas that you want to start addressing as we start moving towards the panel discussion?
Well, we did have some questions in the chat, so I wanted to make sure that we get those answered, and Siamak has been awesome in answering those. So let's just bring that out. So first we have, how are data migrations handled in the event of a rollback with GitOps? And Siamak, do you want to dive into that one?
Sure, actually took credit for like multiple people answering to that, but generally, I think the high level, like conceptually, you shouldn't see GitOps as something that like addresses all the problems around deployment. It focuses really on a single thing and solve that really well. It focuses on Git-driven workflows for everything, not just for your development when you're developing code, but also driving your operation. That's the single problem that is solved. But as a consequence of that, you get a lot of visibility and auditability and traceability because of the Git provider. Right? So that's what it focuses on. When it comes particularly to rollback and switching between versions, so it doesn't really itself do anything for your data automatically. It still relies on the application teams and the operators to be aware of their architectures and the way that they use ArgoCD, or they use the GitOps process to be aware of the changes in data and work that into their process. That said, ArgoCD gives you a couple of tools to be able to work with it. For example, it was mentioned in the chat, it was Christian perhaps, or Shubek that mentioned about the hooks. There are hooks in ArgoCD that you can say to it that before you sync, perform these operations, for example. After you sync, do this other operation, which could be used perhaps for backing up their schema, for example, restoring and things like that. There are also a lot of discussions around, like regardless of what kind of process, this is not a question related to GitOps really, it's related to any type of deployment. How do we manage rollback, regardless of how you perform the rollback, and when it comes to data? So there are a lot of conversations and guidelines also on the application architecture, how the application itself could be more resilient toward changes to the database schema, for example, so that from one version to other, it doesn't immediately break if the schema doesn't match the expectation, or the application also, if the schema for the database, for example, is also lifecycle managed so that the multiple schemas are supported at the same time for a single version of the application. So to summarize it, really, it doesn't give you the silver bullet for how do you do with your data when you're rolling back, but it gives you a little bit of more flexibility if you want, and still responsibilities on the team itself and the operators to use those flexibility, they'll use those tools and plan for how to manage the data between changes of version.
Thanks, Siamak.
Yeah, I'd just like to just kind of add a little bit to what Siamak was saying. Is just there's the tools are out there to do the things that you need to do, right? There's hooks. There's actually a good demo by Intuit that does that uses hooks to put up a under construction page while they do some maintenance, and once the maintenance finishes, it deletes the that page, right, by kind of just showing the idea of A/B deployment and schema changes and things like that. So it's really heavily dependent on the process and the tools that you've and how you leverage the tools to do that process.
So we also had other questions in the chat. Let me find the next one. I love that we have a lot of chat going on. All right. I guess for HA purpose, is it better to have ArgoCD as an external cluster from Openshift? I don't know who wants to take this one, Siamak?
I can talk about it a little bit. So if you look at the role of ArgoCD in this process, it is really in charge of your deployment to make sure what you have described in your Git repo is what you're seeing on your cluster. So what happens if ArgoCD is down, let's say? You completely remove it, undeploy it altogether. The only thing that happens is that you cannot do any new deployments through this GitOps process. So no new releases will be rolled out, right? So I just want to put in perspective the criticality of the role of ArgoCD for the application itself. The applications that are deployed and running, nothing is really happening to them, which is, if you think about it and not using GitOps process, it is essentially what you're doing today, right? You deploy the application and you're done for the day till the next time you want to deploy your application. In between, there is nothing else happening around deployment in between two releases to your production. it is as if in the GitOps world, your GitOps engine is non-existing between those two releases. So it is like from a customer's perspective, or from a lot of our customers that I work with, it's not as, hasn't been as critical as buying into the overhead of running, like thinking about HA for ArgoCD, running multiple instances, or having separate management clusters for ArgoCD. That adds, all of this have, they add the, for the high availability that you gain, there are more management costs and operational costs to gain that. And we haven't seen many of those instances, but if that is needed, is required, so that is definitely one approach, to externalize it from the cluster that is that your application is running on. There are other approaches around HA of the controllers itself to be discussed. There are ways to achieve that, but I haven't seen it very often. I don't know if Christian or Shuvik in the call, if there are others that have seen more use cases around this with customers.
Most of my customers, are less concerned about that aspect because they find the benefits that come with GitOps and ArgoCD outweigh the risks, because this is actually providing more uptime and availability than what they had previously.
And Sam, I hope that answered your question. Yeah, I'm learning stuff too about ArgoCD. All right, so where and how should passwords for different environments be stored? I think Shavik answered this. Yeah. Oh, Andrew, or
Yeah.
Shavik, you're welcome to. Go ahead, Christian.
Yeah, well, there's really two schools of thought, right? In terms of just secrets in general, right? Is either use something like sealed secrets, right, where you're encrypting the secret before you put it in Git, or you use something like Vault, right? You use some sort of secret management system, right? They both have the pros and cons, and there's still kind of a discussion going on in the community in terms of what is actually GitOps. Using Vault is actually GitOps, is it? We don't know. Or is sealed secrets still the way to go? So there's two methods of doing it, right? I don't think either method is right or wrong. It's really what it works for you. I like using sealed secrets, just because I'm more of a GitOps, everything in Git, right? I'm trying to push myself towards everything in Git as much as I can. But yeah, really secret management and storing secrets, encryption really is your friend there, especially if you're really just putting secrets in your Git repository in your environment. So first of all, you have your own personal Git repo inside the environment, right? So like they're behind a firewall, behind multiple layers of security. So you're just adding one more layer of the encryption on top of that. So
You want to add something, Shavik? Oh.
No, I think we are good. I think we've answered and we've covered everything on it. Thank you.
Secrets. All right, and there is a request for the link to the Intuit demo. If anybody, do you have that handy? The Intuit demo.
Yeah, I have it handy. I forgot to I put it in the Twitch chat. I forgot to put it here. I'll put it in on the.
Awesome, thank you.
On the blue jeans here.
Okay, let's see. Can you share the repo with the customized Helm charts that you were deploying from? Another request for you, Andrew.
I can. I'll put that in the chat in a second.
Awesome. And let's see. All right, I'm trying to scroll through all the chats, which is awesome. Hey, Carlos, will ArgoCD still apply, or more like Flux CD will fit here?
Yeah, I think the question by Carlos was something around whether we can use GitOps for cluster state. And I answered that. I think yes, the answer is yes. It's very common to maintain cluster configuration on Git. But of course, to a large extent, as long as you can describe it using manifests, that's how you would do it. So for that, you could do it with ArgoCD or Flux both. Both work equally well with it.
Nice. And Let's see, because Carlos also asked, you guys covered GitOps for keeping the app state, but what about keeping the state of the cluster also in Git?
Yeah,
So
that's what I just answered.
So that I know Christian has talked about that and showed it on his GitOps hour with Chris Short a lot. So definitely take a look at that if you haven't on his happy hour. I believe you're doing one on storage this week, right?
Yeah, this week, Thursday, shameless plug, GitOps Happy Hour, we're talking about storage in GitOps. So on this Thursday at 3 p.m. Eastern time. So
All right,
hot
3
topic.
p.m. Eastern. That's awesome. All right, let's see. And were you using a Helm chart stored as files in Git or a Helm chart release in a Helm repo?
So I did answer this one. I was using a Git-based repository, but one of the benefits of the Red Hat Helm charts, they are stored as releases themselves or as a chart repository itself. So I could have easily gone ahead and used that option in Argo. I just chose to use Git.
Nice, thanks. And all right, manifest files should be stored in a separate repo apart from application code repo. Should manifest files also be stored separate to the application configuration files, which differs per environment? Who wants to take this one?
So I definitely would keep them separate. You could, it really depends. At least putting it on a different branch is key. So they each have a different release cycle. But I've seen from my customers, they do almost every single type you could think of. There is a long conversation of whether you should use a single flat repository with different folders or different branches. So that's certainly a big question and one for discussion in the whole GitOps space.
Yeah, that's definitely something that I don't think technically has been solved yet. But I am a fan of different repos for different things because they have different life cycles.
And Elsie asked, mono repo or separate repos? I think you already answered that, right?
Definitely separate.
I typically do separate, but just for demonstration purposes, I threw it all into one for this example.
All right, could you please double click on configuring event triggers, that activate your GitOps pipelines? For example, when someone changes an application deployment descriptor YAML and checks it into a GitHub repo, what's the underlying tooling, pipeline tooling?
So what you can do is it really depends. You can use webhooks in your Git tool to be able to invoke like an ArgoCD sync, or ArgoCD will just natively be able to pull the change on a regular basis. It depends on how fast you want the change to be applied and rolled out.
Nice. All right, that's it for the questions in the chat. That's awesome. All right, so we have a few more minutes if anybody has any last minute questions. So given all the questions that have been asked and between all of you, I mean, are there any other things that you want people to take away from this discussion today? Because I think we have a lot of follow-on prezos and demos and everything after this one, deeper dive. So, all right. Sam says maybe spoiled question. So what is the state of ACM versus ArgoCD? I don't think that's a versus. Siamak, do you want to take that one?
Yes, sure. So it is exactly like I said, Karena. So there are two tools that sit really well together if you want to apply GitOps across all of your infrastructure, right? So when we say infrastructure as code practices, when we talk about ArgoCD and take time on a CI/CD, the lot immediately lands on the application side. With a little bit of touch of infrastructure, because Kubernetes is a declarative platform and OpenShift really takes it to the extreme with being able to configure everything through YAMLs that you put in Git repo, but it doesn't go really further lower than that. So if I want to provision a cluster, we usually don't talk about that. How do I go from nothing to a cluster on Azure and then roll out my application to it, right? Or if I want to also enforce that once the cluster is up on Azure, there are certain operators installed on it, or the way around. There's some certain operators are not installed on it. There are enforcement of policies on it. So that's where ACM, that's the power that ACM brings to the game, and with the combination of ArgoCD, that it expands the GitOps story or GitOps capabilities beyond just the Openshift infrastructure and all the layers on top, and it pushes all the way down to cluster provisioning and policy governance and aspect like that. In ArgoCD, it's in fact going to be a component within ACM as well that drives the GitOps process there, and really marries well to those provisioning capabilities of ACM and policy part of it. So this is something that you would see roll out gradually over the next 6 months in ACM as well.
Nice. And we have another question. So with multiple repos comes the issue of versioning. App version, config version, manifest version. How do we handle versioning? Will each of these get their own version numbers? I don't know who wants to.
So definitely you definitely want to manage, because just think about it. You may have your application have a different lifecycle than your configuration. Your application may be static for years, but your database password or configurations may change. Let's say you get a brand new image repository location. Your application may never change, but the configuration will. So that lifecycle should be managed separately.
Great question. All right. Well, we have 2 minutes to go. So Freddie, I know you dropped in a link there. Do you have a question about it, or? Okay. Christian already answered.
Yeah.
Yeah, nope.
Can you explain to the people who can't see?
Yeah, so the people who can't watching the recording, they're asking about the Argo Flux join forces. That was an idea they had a while back, and they decided to go separate ways, right? So they decided to they had different goals, so they decided to work on a different approach to that goal. So
I can quickly add to it in general what that means for the community and customers and the industry. So we have a working group where we are all participating together to ensure that the basic GitOps principles, the best practices, we should all have general agreement on that. So irrespective of which tool you use, your paradigm shouldn't be shifted. That should still be similar, the typical GitOps principles or the DevOps principles that we're talking about.
Thanks, Shavik. All right, so Omar, thanks for the this next question. All right, so promotion from dev to prod, for example, and approval gates. Best practices. Would somebody like to talk about best practices for promoting?
yeah, that's part of the CI process, really more than anything else. ArgoCD is just does the CD aspect of it, the CI process of approval gates, and going from dev to prod. That's all done in the CI process, right? So there's been a lot. So Jenkins did a really good good job of like globbing them together. That's why it's CI/CD, right? But really now that we're separating the responsibilities, is your CI process does a lot of that. That gating and that release process, and the sync tool, in this case ArgoCD, is only responsible for actually doing the change that it was told to do. So the approval gates will definitely just still be in your normal CI process. The CD process, that's further downstream.
Thank you. All right, I think that's we definitely have a lot of follow-up stuff and more sessions. I'm loving this. So we are out of time though, and thank you so much, Christian, Siamak, Andrew, for presentation and demo and the great conversation, all the Q&A. We had lots of great chat. So thanks again, and for everybody else, thanks for joining us and all your questions, and we will see you soon. So thanks again for joining us in this OpenShift Commons.
Thanks, everyone.
Thank you.